Good morning, everyone, and thank you for joining. I think there might be still a couple of people that will join us through the course of the webinar, but I think let's get started. So, my name is Ssml. I'm the head of R&D here at Learning Machines, and I'll be your host for this webinar. So, Learning Machines, we are a consulting firm. We specialize in machine learning, big data, and cloud services. And if you want to find out more about Learning Machines, you're most welcome to visit our website at www.learningmachines.co.za. So just so you know, today's webinar is part of our 5-part series where we look at the application of artificial intelligence and machine learning to unstructured data, and particularly to text, voice, and image data. Now, in today's webinar, we're looking at speech and voice processing. But we've also covered, in the previous two webinars, we've covered text. And in the next two, we will be covering the processing of image and video data. And so if you want to register for any of our webinars, please visit our website. I should also just mention at this stage that we will be distributing links to the webinar content later this week. Good. So today's webinar is on speech recognition and text-to-speech technologies. And we will demonstrate during the course of this webinar 2 services that's available from Amazon Web Services, namely Amazon Transcribe and Amazon Poly. At the end of the webinar, there will be a Q&A session. But if you want to ask questions during the course of the webinar, you're most welcome to ask questions in the chat window. I've got a number of my colleagues here from Learning Machines, and they'll try to answer your questions during the course of the webinar. So let's start maybe by looking at language. And language typically has 2 aspects. The one is the spoken form, so humans talking to each other, and the other one being the written form, which of course, if we write down language, is quite a bit different. So the spoken form, of course, being the most natural. Almost everyone on the planet is able, in some way or the other, to communicate with fellow human beings. The written form is perhaps slightly different. So typically, to be able to write language down, you need some form of education. And the written form is typically better suited to knowledge representation. And it's also the form that computers can more readily understand. Now, when we talk about things like speech recognition or speech synthesis, we usually talk about a computer's ability to process human voice. And maybe on the onset here, when we're talking about these sort of different technologies, it's important to realize that in many cases, human voice carry subtle additional information, which is not necessarily present in the written form or the words being uttered. So if you think about things like the rate at which you speak, or the intonation of different words, or if you're pausing in certain places, all of these clues carry additional information, which help humans to communicate better. So Mary Angelou, a famous American poet and human rights activist, she said it quite beautifully. She said, "Words mean more than what is said down on paper. It takes the human voice to infuse them with deeper meaning." And another beautiful quote from her is, "Poetry is music written for the human voice." And so I think while we're discussing voice processing this morning, it should be quite interesting to observe and to keep in mind how far we've actually come with computers and the ability of them to capture these aspects of the human voice. Now, as most of you are probably familiar, you've seen some graphs which take a form like the one that I'm presenting here. The human voice is a form of a sound wave. And so what you would do if you have something like a microphone, you would measure the energy that's present in the disturbances in the air, and you would model the amplitude differences over time. And so for computers to be able to work with these types of representations of voices is quite difficult. It's not so easily interpretable or analyzable in this specific wave function form. And so we need ways to transcribe between voice and text, making it much simpler for a computer to understand, to work with the textual representation of what we are trying to say. Now, before we continue, maybe just a couple of terms that we'll use here. So oftentimes we speak of automatic speech recognition, or just simply speech recognition, which is also called speech to text. And these systems enables recognition and translation of spoken languages by converting the spoken language to text. On the other hand, we have what is called speech synthesis, or text to speech, which does the opposite. So it converts text into a synthesized speech by a computer. Now, these terms, speech to text and text to speech, emphasize that it's a conversion from a textual representation of data. And sometimes, or mostly used as a synonym for automatic speech recognition or speech synthesis. But I think ASR or SS is oftentimes quite larger, and specifically TTS and STT is a subfield of these systems, in the sense that it only works with textual representations. Now, another concept which is quite related is what is called speaker recognition or speaker identification or diarization. And this is about the ability to identify a speaker that's present in the voice. So you might be able to recognize a specific speaker, so you assign an identity to that speaker, or subtly different, the ability to pick up that there's different speakers that take part in a conversation, but you don't necessarily ascribe a specific identity to that speaker. Now let's look at a couple of business use cases where we might use speech recognition technology. So the first one obviously being in terms of productivity. And something like dictation, where you would use the computer to transcribe what you are dictating into a textual representation. This is especially useful if there's a lot of technical terminology involved. So if you think about things like a doctor transcribing medical terms, or in the engineering or legal field, if there's a lot of terminology involved, it's often best if it's dictated by a computer system that can automatically recognize these technical terms and do the transcription, rather than a human being which sometimes struggle or is not able to follow the technical terminology that is used. Things like minutes of meetings or customer service calls are quite often transcribed. If you think about things like chatbots or telephony systems, oftentimes these systems can save quite a bit of money by, as a first line of defense, to have computers involved in the process. If you've worked with anything like YouTube before, you've probably come across closed captioning and subtitling, which is really good for people which have hearing disabilities. Obviously, also, it's perhaps the first step in things like language translation. So you might transcribe what is being said in a video and then use a translation service to translate it into a different language. And often things like newswire services would use speech recognition to be able to capture what is being said in the press, and then have textual representations which is then used for consumption in the news media. In terms of creating content that is searchable, speech recognition is quite valuable. So if you think about the audio and video assets that you might have, many times you have to create metadata, especially for that audio and video signals. But if you can create it automatically, you then create the ability to search these archives and to create searchable content. So if you think about a large video supplier, like something like YouTube or so forth, or a movie database like Netflix, the ability to transcribe that content makes it searchable. And you can exploit the value inherent in those data streams. Then in terms of things like data mining, transcription through speech recognition would often be one of the first steps in your NLP pipeline. So you would transcribe your data, get a textual representation, and then you can do a whole host of things, for instance, say entity recognition or sentiment analysis on that data, which is obviously useful for things like data capturing or monitoring what your sales agents are saying to your clients. Now, if you've been following our webinar series thus far, you will have seen a number of AWS web services, which is geared towards artificial intelligence and machine learning. Now, AWS have what they call the AWS machine learning stack. At the lowest level of the stack are various machine learning frameworks and infrastructures. Some of you might have heard of things like TensorFlow or PyTorch or Keras. And this is sort of the lowest level of the stack, where you get access to sort of the very low level machine learning frameworks. At the middle layer, or the machine learning services layer, Amazon gives you the ability to build your own machine learning models, typically through their service called Amazon SageMaker. And at the very top of the stack is what is called the AI services, which offers a number of machine learning models that you can use off the shelf. Now, in previous webinars, we've covered a couple of these, things like Lex or Kendra or Translate. But for speech recognition, the specific service that they make available is called Amazon Transcribe. So it's a text-to-speech system which use some of the most state-of-the-art machine learning models to transcribe human voice and to try and create an accurate transcription of what is being said. What I should maybe say here is that there's also something called Amazon Transcribe Medical, which is made specifically for the medical industry, to help physicians with their note-taking and so forth, and interactions between patients and physicians, or for things like lab analysis from guys like radiologists and so forth. So I'm not going to go into details about the medical version of it, but I'd like to maybe just take you through a couple of concepts from Amazon Transcribe. So it's been available for quite some time. It's been launched in November 2017. So it's been around for 2.5 years or so. And it's got a couple of features, and I'll talk you through the detail of these features during the course of this webinar. But what I do like about these features is that it's sort of the basic parts that you need to have a high fidelity production system. So first of all, there's support for multiple languages. You do have quite an accurate transcription service, which is maybe rivaled by only a few of the best systems in the world. The ability to do real-time and batch transcriptions. The ability to recognize multiple speakers and generate different timestamps on processing. And then also the ability to work with different types of vocabularies. So first of all, to find your own vocabularies, and then also to filter content based on specific words that you might not want to have in transcription, or to remove sensitive user information. So at the moment, as of July 2020, Amazon Transcribe supports 31 different languages. Now, at this stage, unfortunately, not much support for African languages. You will see the languages there are sort of very much international languages: English, Spanish, French, and some of the other main languages in the world. And for these languages, many of them, it includes various variants. So you can see there, for instance, if you take English, there's, for instance, US or British or Australian versions of those languages. The languages in bold there, specifically in the English, French, and Spanish domain, can be done in real time. So that's quite a nifty feature from Amazon Transcribe. And maybe just to highlight the differences between batch and real time. So if you're doing batch transcriptions, you can provide a whole different set of different audio formats. So typically you would have a waveform, MP3s or MP4s. you would upload these files onto the storage facility of AWS called S3, and you would start a batch job to then transcribe a whole set of documents for you. Now, in terms of real-time streaming, you have the ability to create a HTTP2 connection or a WebSocket connection. And then you can transcribe voice in real time, which is quite useful if you have something, say, like a news service, where you're trying to transcribe what is being said in real time. Or for instance, if you have a customer sales representative talking to a client, and maybe you want to get a textual representation of what is being said in real time. Now let's maybe watch a video here to just give you an idea of what this service entails. So this is President Cyril Ramaphosa's announcement of lockdown. And this is sort of the good portion where I think most of us were still in agreement that the lockdown is a good idea. So let's see what Amazon Transcribe could do with his speech.
In the days, weeks, and months ahead, our resolve, our resourcefulness, and our unity as a nation is going to be put to a test as never before. I call on all of us, one and all, to play our part and our role as South Africans, to be courageous, to be patient, and above all, to show solidarity and compassion to one another.
So if you read the transcript on the right-hand side there, it got most of it right. There's one little mistake there in the days, weeks, and months ahead, which was transcribed there as I had, which sounds quite similar, and I guess where the machine translation made a little bit of an error. But it's quite good, and generally, if you look at the punctuation there, the commas, the full stops, and so forth were placed in exactly the right spots. And so I think it's quite a fair representation of what is being said in the speech there. So you might have noticed that there was a person there doing hand signals, maybe for people that's hearing impaired. And so generally, if you had the ability to translate or to transcribe voice on the fly, you might have also have then projected the text onto the screen for such users. Now, in terms of accuracy, what is quite nice about Amazon Transcribe is the fact that they use some of the newest machine learning techniques, which are continuously trained. And so that gives you the ability then to always have sort of state-of-the-art models running on the background. And then there's no need for you to then sort of do retraining of any machine learning models. In fact, you are quite unaware of the machine learning that's taking place. What's quite impressive is the ability of these systems to handle sort of various acoustic and speech characteristics. So if you think about the background noise that might be present, or different speakers, which all sound differently, different intonations or volume of or speech rates, all of that is being handled correctly. Also things like the automatic addition of punctuation, transcription of things like numbers and currencies and so forth, which it does quite accurately. Also gives you the ability to provide up to 10 alternative transcriptions for each voice input. And so if you have sort of different content and you want to analyze that in a bit more detail or get the right one, Amazon Transcribe gives you the opportunity then to have different transcriptions for that. So let's take a look at some of the additional sort of ways in which it transcribes things like numbers, dates, and currencies. And I've just highlighted a number of different examples here of things that you might find in voice. So one thing obviously that needs to be treated correctly is large numbers. So if someone was saying something like 1,002,029 or something, those types of numbers need to be transcribed in the correct way. Subtle little things like the use of the word to. So if you have something like 2 to 19 there, you would want the system to use the word to as a range indicator as opposed to the letter 2. Things like percentages or currencies like US dollars or Great Britain pound and so forth should be correctly translated, as should things like decimal representations and dates as well. And you can see there, for instance, in that example there, the 12th of May 2012, the word 12 there being used in two different contexts. In one, it's the number of the month of May, and in the other case, it's the number of the year. And it does quite a good job of transcribing those. Now, in addition to just giving you the textual content, it also gives you the ability to identify different speakers. So for instance, if there's a number of speakers, maybe you have a customer representative speaking to a client, or you've got a meeting and there's various participants in the meeting, you might want to have the ability to figure out which person has said what. And so there's an example here, for instance, where I've given the voice which says, do you want to proceed? And someone might say yes, and then the reply might be thank you. And so by understanding sort of the different ways in which different people speak, the machine learning models can pick up that there's different people that had different utterances. And you would typically specify the number of speakers that you'd like to pick up in your audio clip. And that can typically range from 2 to about 10 people. Now, in addition to picking up different speakers, it also have different channels. So if you had different channels, that's part of your recording. It can separately transcribe each of the different channels. It can create timestamp values for you, so you know exactly where any one of the words or so start and end. And it also gives you different confidence values for each word that it picks up in the original voice recording. Now, sometimes there's words that obviously wouldn't be available in the corpus in which the machine learning models were trained. And so you would need to specify custom vocabulary or terminology that is maybe applicable to your domain. So if there's specific terms, again, if we can use the medical example, there might be specific terms that might not be trained for. And so you might want to specify specific terms that should be picked up. And so you would specify what is called a custom vocabulary. Typically, there's two ways to do it. You could use the International Phonetic Alphabet, where you would have different phonemes in your representation. And you would then sort of give an indication to the system that this is the way in which different words are pronounced. Or you could use what is called the sound-like specification, where you would try and describe words that sound in a similar way. In addition, you could also specify how these words should be displayed in your transcribed text. So a good example of that might be if you take my surname, which is Senecal, which obviously, if it comes from a Dutch heritage, and so that might not be something that might be picked up if you were to use it as an input in an English in an English voice, since that would be something like cynical. And so you would need to maybe create a custom vocabulary for a system like this to pick it up adequately. Now, sometimes you would like to remove content from the transcribed text. And there's two ways to go about it. The one being automatic content reduction, and the other being vocabulary filtering. So sometimes there might be sensitive information in the voice. So something like a customer's name or his telephone number, email address, things like PIN numbers or bank account numbers. And these types of content you wouldn't want maybe in a transcription that is sent for further processing. And so Amazon Transcribe gives you the opportunity then to run it through what is called automatic content reduction, where those fields would be blanked out in the transcription. Another thing that you might want to filter out are words that might be profane or obscene or offensive or unwanted in some other aspect. And you can do that through vocabulary filtering. So if suppose you were having a conversation with someone, say with a sales representative, and the customer might have used profane language, you might want to blank those out in the transcription of that text. Let's have a brief look at the cost for these services. So Amazon Transcribe runs at $1.44 per hour, which is quite cheap for this. So if you take something like this recorded webinar, which might run, say, between 30 minutes or an hour, I would probably, if I were to transcribe this, end up paying something like $1 or so to do a transcription. There's a minimum of 15 seconds bursts, so sort of the minimum cost for a short burst of voice that's transcribed would be 0.006 cents. And then obviously Amazon Transcribe Medical, being sort of tailored to the medical industry, is a little bit more expensive, running at about $4.50 per hour, but still fairly cheap, if you ask me. If you think about something like a 2-hour meeting running, it's probably much cheaper to pay $2 or $3 to have that meeting transcribed than to have someone taking notes and maybe doing it inaccurately. All right, so let's maybe move on to speech synthesis then. And let's first of all look at different use cases. So obviously there's things like content creation, where we would now take the text and maybe create an audio transcription for the text. And so obviously people that might be blind or visually impaired, or simply suffer from reading difficulties might benefit quite a bit from such a system. But also just generally translating your content, whether it's articles or your websites, and creating speech synthesis for those might actually assist you in creating quite a bit more consumable content. In the games industry and character animation, there's quite a bit of opportunity here. So characters and in-game text overs that might benefit quite a bit from a system like this. Education and e-learning. So obviously different people learn different styles. Some are more visual, some are more audio focused. And so for instance, just creating an audio book from your content, which might assist people quite a bit. Or for instance, people that want to drive in a car and listen to an audio book as opposed to reading it might benefit quite a bit from a system like this. IoT devices, I'm sure all of you have seen some device somewhere, whether it's your television or your smartwatch or your car, or various mobile apps, all of them being benefiting from text-to-speech systems. Obviously, things like telephony and IVR systems, chatbots, and then announcement systems. So if you think about things like in the public transport sector, calls for airplanes, or things like emergency response systems, which might make announcements. So quite a number of different use cases, things like speech synthesis. Now, the service provided by AWS to do text-to-speech is called Amazon Polly. It's been launched in November 2016, so also quite some time for them to sharpen the system and improve it. It's got quite a bit of different features, so support for different languages. I think probably the most unique feature here is the neural voices that they've developed, which use the sort of most current machine learning techniques. Also support for real-time and batch modes, and the ability for you to control the output of the speech, of which I'll show you an example or two during the course of this webinar. quite easy to use and quite affordable. At the moment, support for 29 different languages, again, sort of focused on international languages. But perhaps more interestingly is the voices that it supports. And so at the moment, there's 61 different voices supported in the system. It ranges with sort of different styles and characteristics. So you could, for instance, have male voices, female voices, and child voices. And these voices are driven by different technologies. So you do have standard voices, which relies on slightly older techniques. But there are newer neural voices, which uses neural text-to-speech capabilities to do the transformations. And I'll show you an example or two, and you can listen to the quality of these neural voices. Specifically, there's been different styles developed for these neural voices. So a newscaster style, which is tailored for news narration, and then also a conversational style, which is tailored to telephony applications, which can allow you to do things like two-way communication and ease a conversational flow, maybe between a client and a system. In addition, you can work with the engineers at AWS to create your own unique brand voice. And then that's a unique service that will assist you in developing your own brand voice, which is unique from any other voice that might have been developed. So if you take a look here, say at something like English, support for various dialects of English. So you might have English spoken in the United States, which might differ quite a bit from British or say Australian English. And probably the one which is supported the best is obviously US English, having different types of voices, which sort of each have a specific identity associated with them. So there might be Johanna or Ivy or Sally or Kevin. And each one of these might then be realized in different ways through the standard or a neural implementation. Now let's listen to a couple of examples, just to maybe give you an idea of what this entails. So I'm going to start maybe by giving you an example of a British English being spoken by Brian. Is quite like this voice. It's got sort of like a news sounding voice. And maybe while you're listening to this, I'd like you maybe to pay attention to the way in which different words are pronounced and where there's sort of pauses in the voice, you know, and what is the quality of the generated voice representation. Let's take a listen.
Learning Machines is a Johannesburg-based consultancy, working with clients from all over South Africa.
Okay, and you can sort of, you've heard probably the quality there and the natural pause after the consultancy. Let's maybe take a different example now. This one coming from sort of an Indian English, and we have Ravina.
We specialize in big data, machine learning, and cloud services.
And I'm sure you can agree with me that there's, you can definitely pick up on the Indian accent there. Again, maybe an example of a neural voice, and this time from a US English.
We help our clients build the complex data architectures, data pipelines, and machine learning models to take their organizations to the next level.
Quite flowing and natural. Now, something that's maybe interesting here is I've applied a French voice from Leah here. And so obviously it's not made to work against English text. Leah would assume that this is French text, but still I think it's quite intelligible. So let's take a listen.
You are welcome to contact us to find out more.
Okay, and so although not necessarily made to work on English text, I think quite intelligible, and you can definitely sort of hear the French accent coming through. So when you're trying to gauge quality with these text-to-speech systems, it's sometimes quite difficult because each person is different and have different physical attributes. And so it's not so easy to quantify how well a text-to-speech system actually does. So typically these types of things rely on subjective measures. One of them being naturalness. So how human does it sound? Does it sound like it's a human giving like a human voice? And then secondly, the intelligibility of the text. Can you understand what is being said? Now let's maybe listen to some ways in which different situations might be realized. So if you look at the sentence there's 1,000 milliliters in 1 kilogram is maybe how a voice would say it. So let's listen to Russell there speaking in an Australian English accent.
There is 1,000 milliliters in 1 kilogram.
Now, important here is that the system didn't say something like there is 1000 ml in 1 kg. It had the ability to correctly interpret what is said there. Also things like homographies, so St. Mary's Church versus a specific street.
St. Mary's Church is on 226 St. Mary's Street.
And you can see that although there's sort of the same phoneme or the same representation of the word ST, in one context it was clever enough to pick up that it's meant to be a saint, and in the other one it's meant to represent the word street. And maybe a tongue twister. So for a bit of dramatic effect, I've selected a child's voice here, so maybe let's listen to that.
Peter Piper picked a peck of pickled peppers. A peck of pickled peppers Peter Piper picked. If Peter Piper picked a peck of pickled peppers, where's the peck of pickled peppers Peter Piper picked?
All right, and so you would agree that Ivy she doesn't struggle and she sort of get her tongue twisters quite right. So I guess these systems are quite good at those types of things. Now, sometimes you need a bit of finer control over the output of these types of systems. And so Amazon Polly supports something which is called Speech Synthesis Markup Language, or SSML, which can control quite a number of different aspects of the generated voice. So for instance, something say like prosody, which talks about the volume or the speaking rate or the pitch, things like custom pronunciations or emphasis, also controlling the speaking style that I mentioned earlier, like the newscaster style or the conversational styles. Something that's quite interesting is the timbre of the voice. And so that's what sort of makes different voices unique. So although people might have the same volume, the same pitch, your timbre is sort of the measure of the uniqueness of your voice. And that's got to do with the vocal tract length. You also have the ability to control that and create a sort of unique sounding voice. What's quite interesting is things like breathing sounds, which adds to the naturalness of voice. So actually, I think one of the biggest complaints is sort of the clarity sometimes with these sort of neural voices. And by adding breathing sounds, it actually sounds quite a bit more natural. What's also interesting is that if you have maybe text that is translated into a different language, in many instances, you want to match the total duration of text. And so there's an option to also then specify the speaking rate based on sort of a maximum time duration, which gives you then the ability to match the output text maybe to an input text length in this case. Now let's maybe take a example of SSML applied to a specific piece of text. In this case, the story of the hare and the tortoise. And the words marked in green there have been changed. So either things like pitches, which are slightly higher or slightly lower, or slightly faster or slightly slower. Let's take a listen.
The hare was running very, very fast, but the tortoise was going very, very slow. The hare jumped up and down, while the tortoise just walked steadily. The hare said in a loud voice, "You can't catch me," while the tortoise whispered softly, "I am not so sure of that."
Okay, and so you can see that by applying these SSML tags, you sort of get a different response, which is obviously good for things like if you were to do storytelling or developing apps that might read stories and so forth. All right, now in addition, you might want to specify specific words which might need to be translated in a specific way. So in any given language, there's what is called a lexicon. Your lexicon is the set of words which carry meaning, and those words are also called lexemes. And these different lexemes can be represented in different sort of textual representations. So something like an abbreviation, like World War II, might be abbreviated as WW2. And so when that specific grapheme is picked up in the text representation, you might want to have the transcribed voice then say something like World War II instead of WW2. Or if you think about the famous singer Pink, which is also often written with an exclamation mark instead of the letter I, you might want the system to say Pink. And so Amazon Polly supports the pronunciation lexicon specification, which is a W3C recommendation, where you can specify some of these translations that should be affected in your text-to-speech system. All right, in terms of output, different options it supports. So first of all, there's various types of audio formats. So you could transcribe your text representation into MP3, OGG Vorbis, or pulse code modulation at different frequencies, depending on the application. It supports both batch and streaming modes. And then in addition to the actual audio, you could also request speech marks. Now, the speech mark carry an additional stream of information about the content, such as timing information, so where specific sentences or words start and end. You could have timing information about specific SSML tags that influence your transcription. And also, you can have a look at sort of different visemes that's present in the text. And the viseme is basically a representation of the way in which your mouth would form a word. So it's the visual equivalent, let's say, of a phoneme. However, there's sort of not a one-to-one mapping between phonemes and visemes. So if you have different letters, let's say a P and a B, both of them would have sort of the same lip shape, but they could sound quite a bit different. And so these visemes are used to enhance the visual experience for the user. So for instance, if we talk about character animations and so forth, these visemes would then be used to sort of do real-time character animation. All right, so let's take a quick code example. If there's any coders in the audience, quite easy to get going with Amazon Polly, importing a library, and then basically sending a request to synthesize speech. It's actually embarrassingly straightforward. Support for various different SDKs, different languages. All the most popular languages are supported there. In terms of cost, there's a pay-as-you-go pricing model, the same as most of Amazon's products. And there's a difference in the cost for sort of the standard text-to-speech voices and the neural text-to-speech voices. The standard voices typically cost around $4 for a million characters, as opposed to the neural voices, which can go up to $16 for a million characters. Quite a nice free tier where you get up to 5 million different characters per month for a 12-month period. And then also what's quite nice about Amazon Polly is that once you've created a specific audio output in a specific voice, you can replay that generated audio free of charge. So once you've created, say, a snippet that you maybe want to integrate with one of your applications, you can replay that audio since it's already been generated before. All right, let's see if we have time for maybe a very short demo on Transcribe and Poly. I think we're running a little bit out of time. So let's do the following. Let's see what's news today. All right, let's see what looks interesting. All right, let's just take the first one here. Gareth Cliff. Let's see. Gareth Cliff reacts to the new alcohol ban and takes aim at Cyril Ramaphosa. All right, let's take a bit of text. And what we're going to do, we're simply going to paste it into the Amazon Poly text-to-speech portion here on AWS. And let's maybe try and listen to what it said. And one of my favorites, let's go here to Brian and listen to Brian sort of say this in a news-like voice.
Controversial radio host and television presenter Gareth Cliff has taken aim at President Cyril Ramaphosa's leadership, again. This comes after Ramaphosa addressed the nation on Sunday, where he announced a curfew would be reimposed and the sale of alcohol would again be banned. Okay, so apart from maybe a slight mispronunciation there of the president's surname, I think everything else sounded quite natural. Let's see what else is news today. Let's see, maybe the Western Cape. All right, let's take a bit of text here, and let's listen maybe to Amazon Poly, some translation of that. And maybe for effect, let's take something else. Let's take an Indian voice, and let's listen to Aditi.
Cape Town. 2 cold fronts have brought much needed water to the Cape, but they've also wrought havoc in some Cape Town communities. Trees have been uprooted and homes damaged, as emergency services teams mop up. The latest cold snap made landfall late Sunday night, causing flooding across parts of the city.
All right, so maybe just some examples of how one could translate, say, some current news into speech. Now let's try something different here, and let's do a real-time transcription of some text. And maybe, let me see if I can maybe read some of these news articles that we just had and see how well it might pick up on if I were to pronounce it. So, all right, let's see how it goes. Two cold fronts have brought much needed water to the Cape, but they also wrought havoc in some Cape Town communities. All right, so if we look there at the sentence that was produced there, 2 cold fronts have brought much needed water to the Cape, but they also wrought havoc in some Cape Town communities. All right, and so obviously the word Cape there struggled a bit to pick that up. But I think you get an idea for sort of the general gist of these services. All right, I think we're running out of time a little bit. So maybe if I can open up the floor, if there's someone that has a specific question, you could maybe just raise your hand and I'll give you a chance.